Special right triangles. So there's a quick note here. It says the acute angles of a right isosceles triangle are both 45-degree angles. Another name for an isosceles right triangle is a 45-45-90 triangle. And that's specifically what we're going to be looking at. That leads us right into what we call the 45-45-90 triangle theorem. So this theorem states that if you have a 45-45-90 triangle, which let's take a moment and look at. Here's your triangle. You have two angles that measure 45 degrees. So there's your 45 and 45. And you have one angle that measures 90 degrees. So 45-45-90 specifically talks about the angle measures within the triangle. Previously, we learned to use the Pythagorean theorem to solve for missing side lengths of a right triangle, but today we're going to look at these special right triangles, this first one being the 45-45-90, and the theorem states that the hypotenuse of this triangle is equal to one of the leg lengths times the square root of 2. Now in a 45-45-90, your two leg lengths are the same. So this leg length here and this leg length here are exactly the same length. If you know one of them, you know the other one. And that is why the formula only includes one of the legs. So let's take a look at an example on how we can apply that theorem to the missing side lengths. In these first two examples, let's confirm that we have 45-45-90, which we do. So we can label our sides. We know that across from the right angle is always going to be the hypotenuse. And we know that the other two sides are the legs. So no matter what, every time you have a 45-45-90, you have congruent legs. So these two leg lengths are exactly the same. Now I'm missing the hypotenuse, so I can use this formula that we just listed, and we can fill that in, solve for the hypotenuse. In this case, the hypotenuse is going to be represented with the variable h. We know the leg length is 9 times the square root of 2, and that is your answer. There's nothing else that can be simplified. Your answer is 9 times the square root of 2. If by chance there was another variable, which you will see quite a bit in other practice assignments, on the other leg length. So here we have the variable h. This side we know the variable or the length is 9. Let's say this variable x was representing the other leg length, and I asked you what is the value of x. Because it's a 45-45-90, you should all be able to tell me that x is equal to 9 because the two sides are congruent. That's just a little extra note on that one. Okay, number 2 will be a little more difficult because well, not really, but we have a radical already in number 2. Anyways, let's take a look. We have 45, 45, and then a 90. So our properties will apply. We know this side is the hypotenuse. We know that we have two congruent legs. So our formula of the hypotenuse is equal to the leg length times the square root of 2 will apply to this. The hypotenuse is represented with the variable x is equal to the leg length of 2 square root of 2. That's the leg length specifically. And we are still multiplying this by the square root of 2. So we do have to simplify. Using our square root properties, we know we can multiply those together. X is equal to 2 times the square root of 4. The square root of 4 is 2. X is equal to 2 times 2. Or we could say x equals 4 as our answer. Okay, next we're going to move on to determining a missing side length using the 45-45-90 triangle theorem. So instead of missing the hypotenuse, you are now missing a leg length. Let's confirm we have a 45-45-90. We do. We can label our sides. We have our hypotenuse, and we have two congruent leg lengths. So once again, we can use our formula that says the hypotenuse is equal to the leg length times the square root of 2. The hypotenuse is a length of 6. The leg length is represented with the variable x times the square root of 2. And here is where you have to solve for x, so you're going to have to isolate the variable by dividing both sides by the square root of 2. That's going to eliminate the square root of 2 on the right side. However, over here on the left side, you are not done because you have to rationalize. This goes back to lesson 1 where we talked about never having a radical in the denominator. And the way to undo that is to multiply the top and bottom by that radical. When we multiply by the square root of 2, the new numerator is going to be 6 times the square root of 2 divided by 2, because 2 times 2 underneath the radical sign would be the square root of 4. Square root of 4 is 2, and that's equal to x. Now we can simplify this further because 6 and 2 are common terms, and you can divide out common terms. So 6 divided by 2 would give you 3 in the numerator times the square root of 2. So the correct answer in our multiple choice section here is B, 3 times the square root of 2. So part 2 says, why do you multiply 6 over the square root of 2 by the square root of 2 over the square root of 2, which is this step right here. So why did we do this? That's what they're asking in this question. And I briefly jotted a note down, and I just said you must rationalize the denominator. You cannot have a square root in the denominator. So in order to do this, you multiply the numerator and the denominator by the same square root. And that same square root is this here. That's why we multiplied the top and bottom by the square root of 2. Okay, and the last question on this page is a description, and you're going to have to draw the triangle. So it says the length of the hypotenuse of a 45-45-90 triangle is 10 inches. What is the length of one leg? So after we've done a few of these, you should easily know how to draw 45-45-90. They all look the same. You have two angles that measure 45 degrees. You have one angle that measures 90 degrees. This is telling us that the length of the hypotenuse is 10 inches. And it's asking us to find the length of one leg. It doesn't matter which leg you pick because both legs are equal or they are congruent to one another. The formula tells us that the hypotenuse is equal to the leg length times the square root of 2. The hypotenuse length is 10. The leg length is represented with x times the square root of 2. And just like the previous problem, we need to rationalize by dividing both sides by the square root of 2. We eliminate the square root of 2 on the right. On the left, we have to rationalize by multiplying the top and bottom by the square root of 2. Our numerator becomes 10 times the square root of 2. The denominator is going to be the square root of 4, which is 2. And this is equal to x. Now you simplify if you have any common terms, which we do. We have a common term of 10 divided by 2. That leaves us with 5 square root of 2 is equal to x. And that here is your final answer. Okay, now we're looking at 30, 60, 90 triangles. So 30, 60, 90 have a different formula, and it's going to follow a similar pattern in the sense of a 30, 60, 90 spells out the angles that you have within the triangle. You have a 30, a 60, and a 90-degree angle. So within a 30, 60, 90, there is two formulas that you need to know. And the first formula is going to tell you that the hypotenuse is going to be equal to the short leg, and I'll explain the length in a second, times the value of 2. The second formula tells you that the long leg is going to be equal to the short leg times the square root of 3. And this is an important note. I think it's helpful. It's always been helpful for me. The short leg is always across from the smallest angle. So if 30 degrees is your smallest angle, the short leg is directly across from that. Okay, so one thing that does become a little challenging about 30, 60, 90 triangles is that the order of the formulas that you use is different every time. So you're not always going to be using, say, this formula first and this formula second. You might have to switch them up. So you start with the formula that works based on the information that is given to you. And I'll explain that as we go through the next examples. Before we start our problem as far as solving, we need to verify that we have a 30, 60, 90, which we do. We have 30, 60, and 90 degrees for our angle measures. From here, I need to label my sides. So don't forget that the hypotenuse, no matter what, is across from your right angle. And the other trick that I said was that it's up here, the short leg is always, the short leg is always across from the smallest angle. So here's 30 degrees. Across from 30 degrees is going to be your shortest side length, which leaves the last side as your long leg. Okay, now we have two formulas to choose from, so which one do we start with? And I have a note that I find to always be helpful, and the note says, because we are given the length of the long leg, you want to start with the long leg equation. So you always want to identify what you have and how you can apply it to one of these formulas. Oops. If we're starting with the long leg equation, that means we have enough information to fill in this equation here. And I'm going to substitute in the fact that the long leg is equal to 5. I know that this is equal to the short leg, which is represented with the variable d, times the square root of 3. I need to solve for d, so I'm going to divide both sides by the square root of 3, which also requires me to rationalize. So I have to now multiply the top and bottom of this fraction over here by the square root of 3. My numerator becomes 5 square root of 3 divided by the denominator, which is the square root of 9, and the square root of 9 simplifies to 3. This is the value of the short leg. You do not type it into your calculator, you leave it just like this. And now that we know the length of the short leg, we can use the other formula and we can solve for the hypotenuse. My note says now that we know the length of the short leg, we can solve for the hypotenuse, which requires us to use this formula here. So if the hypotenuse is equal to the short leg times the value of 2, I can see that my hypotenuse is represented with the variable f. So substitute f in for the hypotenuse. This is equal to the short leg, which we just found. The short leg is 5 times the square root of 3 divided by 3. And we're multiplying this by a value of 2. Remember that 2 is technically over 1, and when you multiply fractions together, you multiply the common terms in the numerator and the common terms in the denominator. So our numerator common terms are 5 and 2. When we multiply those together, we know that the value of f is going to be 10 times the square root of 3 divided by 3. You cannot divide out that common term of 3 because it's not technically a common term. One of them is a square root, one of them is not. So you can only divide or multiply when you have common terms. Okay, now let's take a look at number 2, which is going to be a 30, 60, 90 triangle because I see my angle measures, but I'm actually going to flip how I start this equation. So I notice that here I'm given my hypotenuse. So in the previous one I was given the long leg, in this example I'm given the hypotenuse. The short leg is across from the smallest angle, so x represents your short leg, and then the remaining side is your long leg. So because we are given the hypotenuse, we have this length right here. That means we need to start with the equation that includes the hypotenuse. So I'm starting with the equation that says the hypotenuse is equal to the short leg times 2. And when I substitute in my values, the hypotenuse is 10. The short leg is represented with the variable x times 2. In order to solve for to solve for x, you divide both sides by 2, and x is equal to 5. Now that we have the length of the short leg, we can use that to find the length of the long leg. So we can use this formula that says the long leg is equal to the short leg times the square root of 3, and we can apply that to this problem. The long leg is represented with the variable y. We just found the length of the short leg. It's 5 times the square root of 3 is what the formula tells us. And we actually can't simplify anything here, so this right here would be our final answer for the long leg. Throughout this note sheet, we learned about two different triangles. We learned about a 45-45-90 and a 30-60-90 triangle. Each of them has their own set of equations or formulas to use, so make sure you clearly identify which triangle you're working with and you clearly identify the correct formulas. I would like you all to try the on your own section by yourself. I'll put my answers up here so you can check over them, but you should be doing this work and making sure you can get through this on your own, maybe with a little bit of help of looking over my work. Please let me know if you have any questions and have a great day.